Good afternoon, everyone, and welcome to the third in a series of 4 webinars developed by Scottish Government Building Standards Division and Construction Scotland Innovation Centre. These webinars have been designed to disseminate the new requirements for Automatic Fire Suppression System, AFSS, into housing. For those who don't know me, my name is Fiona MacDonald and I'm an Innovation Manager at Construction Scotland Innovation Centre. Delighted to be joined today by Keith McGilvery, Danny Doherty, Benny Rooney, Bettina McDowell and Ari Brand, all of whom are currently leading on the new requirements. Before we get underway, I would just like to highlight some housekeeping points to keep the webinar running as smoothly as possible because we do have large numbers today. Firstly, the session is being recorded and presentations will be available following the 4th webinar, which has been held on the 18th of March. All participants will be on mute for the duration of the webinar, but I do encourage you to ask as many questions throughout as you can. To do so, click on the questions section of the control panel, type in your question and press send, and we will try to answer as many as we can during the Q&A session. Your feedback and opinions are extremely important to us, so we do note each and every question, and if we don't have time to answer them all today, we endeavour to incorporate as many of them as we can into the series for the future. There will be interactive polls displayed on your screen throughout today's event, and please answer them and we can display the feedback for everyone to see during the webinar. I appreciate some of you may not be aware of what we do at Construction Scotland Innovation Centre, and therefore I wanted to take just a couple of moments to outline some of the work that we undertake and how the collaboration with the Building Standards Division came to be. So bear with me one moment. So Construction Scotland Innovation Centre. We are very much so the innovation centre that's focused within the built environment. We consider ourselves and innovation to be the beacon for progress within a built environment, and we are responsible for ensuring changes are made to our industry that make us a more sustainable, relevant and aware of society's changing needs, all with a view to create the best economic outlook that we can for Scotland. So we see innovation as the change that unlocks new value, it unlocks change and it unlocks progress. In terms of the Innovation Centre programme, we are one of 7 innovation centres set up throughout Scotland, and we're all collaboratively funded through Scottish Government, the Scottish Funding Council, Scottish Enterprise and Highlands and Islands Enterprise. We see very much so our connected ecosystem as being one of our most valuable assets. Ultimately, we've been working for the last 6 years to progress and develop and create a collaborative industry and public sector and academic response to innovation, and this network of organisations and industry contacts can be pulled and levered in the right direction to support your innovation needs. What we've done over the last few years, these are just some of the headline stats that demonstrate some of the value that we've created through our innovation projects. Most notably, the jobs safeguarded and the jobs created, but also most interestingly is the new business models and improved business services, including new services that we've delivered to market. And really, ultimately, we are on our own evolution here at CSIC as well. We are looking to focus our efforts to deliver more impact when it comes to achieving net zero carbon throughout innovation. And you know, the stats that are on the screen just now speak for themselves in terms of the materials we use within the UK and the carbon emissions that we create. We do focus our efforts across 4 key themes: digital transformation, advanced manufacturing, building sustainably, and culture. And we see these 4 pillars as of activity being underpinned by net zero carbon in our efforts to make change. So we have a number of service offerings, but they are developed into 4 key themes, 4 key streams. Our connected ecosystem, which I've touched on before, and that's how we came to be collaborating today with Scottish Government's Building Standards Division. Our collaborative projects, where we can pull collaborations together. We can use this connected ecosystem to fill the gaps and create the appropriate expertise. And we also support the collaborative projects through our innovation funding, whereby we can buy out academic expertise to unlock the innovation project. Our innovation factory, we have a factory based out in Blantyre, very much so within the theme of sustainability and off-site construction. And this is really an accessibility opportunity for our wider industry and for our public sector and academic partners to access, train and develop using some of the equipment that they couldn't access beforehand. And future skills is very much so cutting edge, developing a cutting edge approach to skills and training, whereby we appreciate that the legacy ways of developing the future generation of construction could offer us opportunity for improvement. So we are trying to make learning more immersive and trying to make construction a more industry of choice for the next generation. Some examples of our work, just to give you some context, the K-brick, it's the world's first recycled brick. It's very close to market, and it's a brick that's made out of 90% of difficult to recycle materials, and at end of life it is simply reprocessed into a new brick. So the fact that it's very circular ticks all our sustainability boxes, and it's completely innovative, and as I said, it's very close to market and something that we're hoping to support them in mainstreaming in the future. Offsite Solutions Scotland is taking the appreciation for our industry in terms of the competitiveness and protectiveness of IP and research. And actually what we did here was develop a collaboration, taking all this taking a number of Scottish offsite manufacturers and builders and creating them, pulling them together to create their own entity, which in turn lets them share the risks, share the rewards when it comes to R&D, but also positions them more competitively for future opportunities of scale for Scottish contractors. Glulam Solutions, this is very much so on our radar in relation to cross-laminate timber. Cross-laminate timber in CSIC terms and the opportunities for economic impact are significant if we can unlock the forestry opportunities and we can mainstream CLT as a building material. There's a lot of opportunity there for all those involved. So we do a lot of exploration work to see where the limitations, challenges are when it comes to CLT, and this is one of them. And the remote building inspection framework is combining AI and virtual reality for defect detection. So when you consider how it is at the moment in terms of the life as we know it in a COVID-19 world, anything we can do that supports accuracy and distance operations is clearly an opportunity. And being COVID smart, appreciating that we have a very big industry with a great representation of SMEs in Scotland, and ultimately having that place to go for advice as relevant as possible. This is something that we delivered during the COVID period. And ultimately, yeah, if you are working with any contractors or clients from your point of view, any of the government representatives, and you think there's potential for innovation, we would be delighted to hear about it. So please don't hesitate to get in touch in the future. And hopefully, just by going through today in terms of setting the scene, we have presentations from Benny Rooney, we have Danny Doherty and Keith McGilvery at the British Automatic Fire Sprinkler Association, Bettina McDowell from International Water Mist Association, and then we'll be joined at the end by Ari Brandit with Bettina and the other presenters for the Q&A sessions. And as we said before, there will be polls throughout, so please don't hesitate to take part because the results are really quite interesting for everybody. And at this point in time, it is time for our first poll, just to see what the results are. So have you, the poll in relation to kicking this off is, have you looked at the key changes to the 2020 edition of the Technical Handbook, which come into force on the 1st of March 2021, or came into the 1st of March 2021? If you just want to take part and your response, we would be delighted. Thank you. Excellent, interesting response. So the majority of people have looked at parts of it, which is interesting, and obviously 32% yes and 33% no. So thank you very much for giving us your results. That's enough from me. Moving on to our first presentation from within Scottish Government, I would like to introduce Benny Rooney. Benny joined the Scottish Government in 2019 in the role of Senior Policy Officer, Technical Author for Section 2 Fire within the Building Standards Division. Prior to taking up this post, Benny worked with the Scottish Fire and Rescue Services for 31 years. The time spent with SFRS was split between operational roles and fire safety enforcement roles. Benny now represents the Scottish Government on various technical committees and steering groups and advises Scottish ministers on all aspects of design and construction in relation to fire. Over to you, Benny.
Thank you very much, Fiona. And thank you very much for Construction Scotland Innovation Centre for hosting this morning's event. So I'm here to give you an insight into the changes in regard to automatic fire suppression systems due to come into force on the 1st of March 2021. So over the next 20 minutes or so, I'd like to give you a wee bit of an insight of what I'm going to cover. So first, I'd like to give you a background of some of the research that was conducted into sprinklers, and I want to focus on the key changes to Standard 215 and the support and guidance, as well as the consequences and the impact this has had on the guidance to Standard 2.9 Escape in the domestic handbook. And to finish, I'll provide a very quick skim through some of the miscellaneous changes made to the 2020 edition of the technical handbooks, and finally touch on some of the wider Scottish Government fire safety work that's currently ongoing. In May 2015, Optimal Economics were commissioned by the Building Standards Division to undertake a research project to provide an updated position on the cost effectiveness of providing residential sprinklers in Scotland. Previous research had been undertaken by the for the Scottish Government in 2009, and this concluded that the installation of fire suppression systems or sprinklers conforming to BS 9251 was not cost effective for dwellings in Scotland. And similar conclusions were reached by the BRE study commissioned by the Chief Fire Officer Association in 2012. This also found that the sprinkler systems were not cost effective for all dwellings. As we know, the benefit of sprinklers depends critically on how effective they are at preventing fires from developing to a point at which deaths, injuries and serious property damage occur. And the main aim of the Optima research was to undertake an up-to-date cost-benefit analysis for the installation of fire suppression systems in certain building types in Scotland, namely houses, flats, houses in multi-occupation and halls of residence. And the study involved collecting information available on the prevalence, risks and costs of fires in dwellings in Scotland and on the cost of installing and maintaining sprinkler systems. And as we know, death, injury and damage from fire are not evenly spread across the population. Relative to population, the number of fires, deaths and injuries are higher in deprived areas than in the rest of Scotland, and is higher still for single persons living alone, for older people and for people affected by problems related to the abuse of alcohol and drugs. The evidence gathered by the report indicated that the most of these deaths and injuries and much of the damage caused by fire would have been prevented had the properties concerned been fitted with sprinklers. The research found that for houses, the installation of sprinklers in single-family dwellings was unlikely to be cost-effective, that for flats, that sprinklers could be installed at the lower end of the estimated cost, installation was marginally cost-effective. For houses in multi-occupation, that there was a marginal cost-benefit case for the sprinkler installation, again, if cost could be driven down. And for halls of residence, the cost-benefit calculation showed that relatively strong case for requiring sprinklers in such halls, given the low unit costs. The report also found that people at risk, for example, those living in deprived areas, single men and people with problems related to alcohol and drugs, are disproportionately affected by fire risks, indicating that while sprinklers are not the answer to all these problems, targeted installation of sprinklers to benefit these groups, if achievable, would be likely to be cost effective. So immediately following the Grenfell Tower fire on the 14th of June 2007, a ministerial working group was convened to oversee a review of building and fire safety regulatory frameworks with a particular focus on high-rise domestic buildings. The group's remit was to identify and take forward immediate actions in order to provide appropriate reassurance to residents and communities about their safety. In addition, the group was to identify medium to long-term actions to be taken forward, which included fire and safety advice and the adequacy of current fire and building regulatory frameworks. As you can see from the slide, this involved setting up a review panel on fire safety standards, which has resulted in changes to fire safety standards. And these changes include the cladding and requirements on buildings over 11 metres, escape provision in domestic buildings over 18 metres, and the introduction of sprinklers to a wider range of housing from 2021. And the review panel included both UK experts and international expert subgroup. Next, setting up a review panel on compliance and enforcement, which has resulted in the strengthening of procedural guidance related to safety critical issues. This review panel has now completed its work, but further implementation is being addressed through the Building Standards Futures Board. And finally, setting up a fire safety regime review advisory group to ensure comprehensive protection to residents of high-rise domestic buildings. Changes were made, as you know, to the technical handbooks in October 2019, with the work of the Futures Board continuing on the 7 work streams, whilst implementation of the 6 recommendations of the review of the Scottish fire safety regime continue. The recommendations of this review were specific fire safety guidance aimed at all residents of high-rise domestic buildings, the introduction of Scottish guidance concerning fire safety in purpose-built blocks of flats, the introduction of Scottish guidance concerning fire risk assessments, a consistent position regarding the storage, removal and enforced prohibition of combustible materials in common areas to be advised and agreed by all relevant stakeholders, a fire safety campaign relative to common areas, and the introduction of Scottish guidance concerning fire safety in specialised housing. So in January 2018, David Stewart MSP lodged a proposal for a private member's bill to require all new build social housing and existing high-rise social housing to be fitted with automatic fire suppression system. Mr Stewart subsequently amended his proposals to apply to new build housing, social housing only, and 354 consultation responses were received, and the bill received cross-party support from 60 MSPs. The Scottish Government then agreed to take over the bill in June 2018 to give Mr Stewart's amended proposal full effect within the current Parliament. At the same time, between June and September 2018, the Scottish Government consulted on a range of proposals to improve compliance with fire safety and building regulations, including escape, cladding and automatic fire suppression systems, and all new flats and maisonettes and certain new build HMOs. And we received a total of 222 responses to the consultation from individuals and organisations. 246 individuals attended World Cafe events in Edinburgh, Stirling, Glasgow and Aberdeen, and changes were subsequently introduced in October 2019. In summary, 2 public consultation exercises were carried out, one by David Stewart MSP in relation to social housing and the other by Building Standards Division following advice from their expert review panels. It was agreed to defer proposals for AFSS under Building Standards and combine proposal into one package, including a commitment for AFSS and social housing before the end of the current parliamentary session. So a summary of the key changes to the guidance within the 2020 edition of the technical handbooks can be found at the link shown here, and a full list of all the latest changes can be found in clause 2.0.5 in each of the 2020 technical handbooks. And the Building Scotland Amendment Regulations 2020 were laid in the Scottish Parliament on the 9th of September 2020 and applies to building warrants submitted on or after the 1st of March 2021. The Scottish Statutory Instrument, Policy Note and detailed information on costs and benefits is contained in the Business Regulatory Impact Assessment, which can be found in the supporting documents on the legislation.gov.uk website. So the Scottish Statutory Instrument, the Building Scotland Amendment Regulations 2020 legislation amends Standard 215 contained in Schedule 5 of the Building Regulations and requires automatic fire suppression systems to be installed in all new build flats and maisonettes, whereas this previously applied to high-rise domestic buildings over 18 metres, but now applies to flats and maisonettes of any height, social housing dwellings and shared multi-occupied residential buildings. The legislation also applies to certain conversions that we'll talk about in a couple of minutes. And so here's just a reminder of a couple of existing definitions. So there's no change to the existing definition of a flat. A flat means a dwelling on one story forming part of a building from some other part of which it is divided horizontally, and includes a dwelling of which the main entrance door and associated hall are on a different story from the remainder of the dwelling. There's also no change to the existing definition of a maisonette, and a maisonette means a dwelling on more than one story forming part of a building from some other part of which it is divided horizontally. The definition of a social housing dwelling is, however, new, and a social housing dwelling means a dwelling occupied by virtue of a Scottish secure tenancy within the meaning of Section 11 of the Housing Scotland Act 2001. The definition of a shared multi-occupied residential building is also new. And a shared multi-occupied residential building means a residential building occupied as a sole or main residence by more than 6 individuals, where those occupying the building or part of the building share the use of sanitary facilities or facilities for the preparation of cooked food with other persons occupying the building or part of the building. Moving on to conversions, there is no change to legislation for conversions. We still have the same 10 generic types listed in Schedule 2 of the Building Scotland Regulations 2004 as amended, and the following examples will give you a flavour of how the standard applies to conversions. So for a Type 1 conversions, apply to changes in the occupation or use of a building to create a dwelling or dwellings or part thereof, for example, conversion of a non-domestic building to flats. A Type 3 conversion applies to changes in the occupation or use of a building which alters the number of dwellings, for example, the conversion of a large house to social housing flats. And a Type 7 conversion applies to changes in the occupations or use of a building so it becomes a residential building. For example, conversion of offices to shared multi-occupancy residential buildings with more than 6 residents. As the standard applies to new build and certain conversions, not all low-cost affordable housing will be caught by the new standard. For example, existing houses renovated or refurbished into social housing dwellings. The recommendation is that these buildings should have automatic fire suppression systems installed, but there is no legal requirement to install automatic fire suppression system, and it therefore becomes a moral and ethical question for the client. We will, however, continue to monitor the market and consider whether a full conversion Type 11 from dwelling to social housing dwelling will be merited in the future. Currently, we estimate that approximately 80% of all social housing will be new build, although clearly this dynamic might change with time. So in relation to fire suppression systems, sprinkler system to BS 9251 are perhaps the most common and well understood type of automatic fire suppression system, and Keith and Danny from BAFSA will talk about these systems a little bit more detail in a few moments. New standard for automatic water mist fire suppression was published by the British Standards Institute in 2015. And whilst water mist is common in offshore and within the marine industry, it is less common in domestic and residential markets. Care is therefore needed as water mist systems are bespoke to individual manufacturers and may be sensitive to small design changes. Therefore, a water mist system should be designed and installed in accordance with BS 8458 2015, and the nozzle should comply with BS 8663 Part 1 2009. Fire performance tests are of course critical, and as BS 8458 relies on this data to determine the system design. Water mist specialists should provide declarations of conformity at all design stages, providing an initial notice and final stage with all details and changes declared. In relation to innovative systems using the domestic plumbing or gaseous systems, the applicant and the verifier should satisfy themselves that the alternative system has been designed, tested and approved for use in domestic and residential buildings, and they are fit for their intended purpose. That is in accordance with Regulation 8 of the Building Scotland Regulations 2004, and Bettina or perhaps Ari from the IWMA will talk about mist suppression in a bit more detail shortly. A good example of an innovative system is a portable personal protection system using an approved third-party certified portable mist unit actuated by smoke detection. These systems are not considered suitable means of satisfying the requirements of Standard 215, but they may be beneficial in some unique situations in existing dwellings to assist in the protection of vulnerable occupants. I should also mention that there is no intent to change the normal consultation with the Scottish Fire and Rescue Service through Procedural Regulation 11. That is, there is no change to what local authorities have done before with regard to mist or other forms of suppression systems. Some authorities may have treated mist as an alternative approach under Regulation 11, where others would not have seen these systems as alternatives on an equal footing. Alternative approaches in the context of Regulation 11 are generally fire engineered solutions, and from first principles or where the guidance in the technical handbook has not been followed. It may be that an alternative suppression systems are entirely appropriate to deal with a particular hazard, for example, a foam suppression system for fuel fires, etc., and the use of the word alternative may be misleading in this context. Less common or simply other forms of suppression may be more appropriate. In conclusion, we do not see that mist, fog, foam, gaseous suppression systems should be treated as alternative fire engineered solutions for the purpose of Regulation 11 and may be entirely appropriate depending on the hazard and risk. Appropriate test evidence and assurances should always be sought regardless of which suppression system is proposed. That is, it must be suitable for the intended purpose as required by Regulation 8. Clause 215.0 indicates that the Association of British Insurers Study post-Grenfell research on residential sprinkler systems provides additional guidance on issues to be considered to improve performance and in the procurement of residential and domestic sprinklers, and is available on the ABI website. The general intent is to ensure design, installation and maintenance are carried out correctly to reduce the risk of damage due to the escape of water. However, I must stress that the escape of water is a big issue for the insurance industry and cuts across all drainage, heating and plumbing installations, so it's important that this is read in some context. Clause 215.1 in the domestic technical handbooks and clause 215.6 in the non-domestic technical handbooks both cite BS 8458 2015 for water mist suppression systems and have equal status, that is, within the guidance. Guidance commissioned by the Welsh Government to the British Research Establishment is due to be published in the coming months, and this guidance will assist building standards verifiers when making decisions about water mist and fire suppression systems. The guidance in clauses 215.2 to 215.4 covering sheltered housing complexes, flats and maisonettes and social housing dwellings all refer to BS 9251 sprinkler systems. This does not mean that mist suppression systems cannot be used. The guidance simply reflects that BS 9251 systems are more common and well established, and that mist suppression is relatively new and require further checks to be made prior to the approval in accordance with clause 215.1. It is worth noting that Scottish Water had published a policy note on their website titled Sprinkler Systems for Domestic and Residential Occupancies, and we strongly recommend that housing developers consult Scottish Water and the suppression system contractor early in the design process. Benefits could also be gained through economies of scale with agreed provision of a communal water supply tank and pumps. And the planning authority should of course be consulted as part of this process. Clause 292, table 2, table 2.3, escape within dwellings has been split into 3 separate tables in standard 215. This includes 2.3a, escape within houses other than the social housing dwellings. The guidance for escape within houses has remained unchanged, and as you can see from the slide, social housing dwelling has its own table at 2.3c. 2.3b, escape within flats and maisonettes other than social housing dwellings. This guidance has changed from that previously as a consequence of the mandatory standard of AFS to all flats and maisonettes. And hence, early warning, for example, an LD1 category, the detection throughout is now an option to choose or provide a protected enclosure. There is no time to go through all of this today, but I would suggest that it would be beneficial for you to look at all the 3 tables closely. 2.3c, escape within social housing dwelling, and this table includes all social housing dwellings in one place, whether a house or a flat or a maisonette. All the tables are self-explanatory, but it's worth spending a bit of time looking over them.
Just a 5-minute warning, thanks Benny.
As most of you know, an escape route is defined as a route from the entrance door of a flat or maisonette. So what we're talking about here are the escape routes and the common areas. The common areas do not need to be fitted with AFSS unless forming part of a compensatory feature in a fire engineering strategy. Clearly, if the client specifies AFSS in the common areas, then there is the prerogative to apply a higher standard than that contained in the technical handbooks. So table 2.4 in clause 2.9.10 has been simplified and all references to AFSS have been removed from this table. Clause 2.06, a flat or a maisonette entered only from the open air at ground level with no story at a height of more than 4.5 metres should be regarded as a house and follow the guidance accordingly. An exemption was added to this clause to ensure that all flats and maisonettes were now caught by standard 215. Considering the new definition of shared multi-occupancy residential buildings, we took the opportunity to amend the guidance in an attempt to provide clarity around HMOs and whether they fall within the scope, whether they fall within the domestic or non-domestic technical handbooks. So the bottom line for HMOs, new build flats, maisonettes or cluster flats with up to 6 individuals sharing, AFSS is required. New build shared multi-occupancy residential buildings with more than 6 individuals sharing, AFFS required. Certain conversions, as explained earlier, AFSS is required. Also, the intention is that student accommodations, flats, halls and residence, etc. are also caught by the standard. Reference to published guidance updated. For example, specialised housing guidance has now been published. Previously it was in draft form. References to British standards have been updated. For example, BS 8414 is now the 2020 edition. And BS 9414 is now published again, and this was previously in draft form. Typographical errors have been picked up, and it's all listed in clause 2.0.5, and the latest changes as described earlier. We have updated the guidance in clause 2.14.8 relating to evacuating systems for the Scottish Fire and Rescue Service using domestic buildings with a storey more than 80 metres. And remember that these systems were introduced on the 1st of October 2019 and not to confuse with fire alarm systems. They enable the Fire and Rescue Service to initiate operation of evacuation alert sounders within each dwelling on any single floor, multiple floors and the entire building according to the circumstances. In very large or very tall buildings, there may be a need to have sub-panels connected to a data network using cables of enhanced fire resistance. And additional guidance is also provided in fault monitoring and location of cables in areas of low risk. If installed in existing flats of mixed tenure, there's a risk that not all flats will have sounders installed. In such cases, additional equipment will be necessarily close to the panel to indicate to the Fire and Rescue Service those flats in which sounders have been triggered and those which are void of devices. Indicated at the start of the presentation, a ministerial group on building and fire safety has met since 2015 to oversee reviews of building and fire safety frameworks, regulations and guidance, and any other relevant matters to help ensure that people are safe in Scotland's buildings. The initial focus of the group was on high-rise domestic buildings following the Grenfell Tower fire in London, but has also considered other buildings including housing, the NHS estate, schools and prisons. And actions taken by the ministerial group include introducing requirements for smoke and heat alarms to be fitted in all homes, setting up a review panel on fire safety standards, setting up a review panel on compliance and enforcement, setting up a building standards futures board that will take forward longer term changes to the building standards system to improve compliance with regulations, and setting up a fire safety regime review to ensure comprehensive protection to residents of high-rise domestic buildings. It's developing an inventory of high-rise domestic buildings in Scotland and setting up a technical working group to develop a Scottish advice note and determine the fire risk posed by external wall systems in existing multi-storey residential buildings. So in the time since the tragedy of the Grenfell Tower fire, the Scottish Government have undertaken a range of actions in order to help make Scotland's buildings even safer. And whilst we are confident in our building standards, we are not complacent, and that is why I've established reviews, sought expert advice and have implemented the recommendations made. Reflecting that, the Minister for Local Government, Housing and Planning instructed officials to convene a fire safety review panel to examine how we can ban the highest risk cladding panels from buildings. This panel will also consider whether changes are required to the mandatory standard for fire spreading external walls, the role of the large-scale fire test BS 8414, and consider the question of competency in the context of the design, installation and verification of cladding systems. The review will be advised by appropriate experts who will use the most up-to-date evidence available to provide recommendations for further changes to building standards if required. And the second meeting of this group is due to take place in March, with the review set to take up to 12 months to complete. The Ministerial Working Group and Building Standards Futures Board website provide details of the work of the work undertaken and are good sources of information to keep up to date with any developments. Finally, thank you for your time today, and I hope I've managed to provide you with some insight into the new regulations and guidance for automatic fire suppression systems and given you an overview of some of the changes coming into force on the 1st of March 2021. Thank you very much.
Thank you very much, Benny. A very informative and comprehensive presentation, so thank you again. Just a note to the audience, if you have any questions for Benny, please don't hesitate to use the questions chat, and these will be circulated within the Q&A session, and we'll answer as many as we can. Just moving on to our next poll. to engage with you guys as an audience, so we can have our second poll, please. On a scale of 1 to 5, how much knowledge do you have of automatic fire suppression systems? Just give you a moment to finish that. Excellent, thank you. Thank you. That's some really interesting results there, and it helps us gauge the knowledge base. So thank you for taking part there. Just going on to our second and third speakers for today, introducing Danny Doherty and Keith McGilvery of British Automatic Fire Sprinkler Association, BAFSA. Just in terms of some context of the experience, Danny Doherty is the Scottish coordinator of BAFSA. Danny joined BAFSA in 2015 after served his fire service for 31 years. He was formerly the head of fire safety enforcement and fire engineering at Strathclyde Fire and Rescue, and Danny is BAFSA's Scottish representative and has actively pursued the adoption of suppression systems in the wider built environment. Currently runs his own fire consultancy business, and for his sins is a director at Hamilton Academical Football Club, so where you can see him most Saturdays with his head in his hands. Keith McGilvery is the Chief Executive at BAFSA since 2015, and Keith was a private fire risk management consultant since January 2009, provided advice to private and public sector organisations on fire-related subjects, together with marketing and lobbying on behalf of fire industries. Keith was also former director of National Fire Protection Association, USA, within the Fire Services section, providing a European perspective on worldwide fire and rescue problems. And for the last 15 years, Keith has lobbied for automatic fire sprinklers in Scotland. He's encouraged central government, local authorities and commercial organisations to fit sprinklers. He advocates that fitting sprinklers to protect the old and vulnerable together with our firefighters. So firstly, over to you, Danny.
Okay, give me a second here just to get this up and running. Right. Okay, thank you for your introduction, Fiona. We intend to split this up so I don't bore you for too long. I'll speak a little bit about sprinkler effectiveness, and then Keith will speak a little about the kind of technical aspects of it. So moving on, the humble sprinkler. It's been around since the mid-1800s, and we're all pretty familiar with what it looks like. But it's actually quite surprising how little many of us actually know about it. It can look something like this, or indeed in a kind of domestic setting, it looks far less institutional, where the head is concealed by a cover plate which sits flush to the ceiling, and that plate can be changed to suit the colour of the surrounding decor. So what do they do? And forgive me, I see that there's some people already know quite a bit about it, but there's also some people that don't. They are an independent heat-seeking element that sits in a range of pipework. The one shown earlier will operate around 67 degrees. The liquid will expand, the glass will break, and the water will then be released. And contrary to what you see in some programs, only one head will operate at a time. Another sprinkler head will only operate whenever that reaches, in this particular case, that 67 degrees. Every system has its own alarm and will actuate when the head operates. It will automatically apply water to the fire area, controlling the size and growth, and will then subsequently reduce the toxic effects of smoke. In doing so, that will prevent flashover development, which is the point at which there is so much heat being radiated back into the contents of the room from the fire and the hot gases that everything will automatically ignite. By applying water on the fire, it will increase evacuation time and will obviously subsequently allow more time for the fire and rescue service to attack the fire. As such, it will protect firefighter lives. It can and will reduce at times fire damage by up to 95%. And that, we hear at times people saying things like, well, the sprinkler system will cause more damage than the fire. And to be perfectly honest, that's coming from people who don't really know the consequences and utter devastation that a fire can and will cause. I'll give you an example. If I was to meet you in the street tomorrow and I offered you a £50 note, you'd say thanks very much. But if I said, well, I'll tell you what I'll do, I'm going to set a match to it first of all, and then you can have it. Or I'll take the same £50 note, I'll put it in a bucket of water, and then you can have it. I know what you're going to take. £50 note might be wet, but it's salvageable and still can be used. So moving on. What we have is a typical front room house fire in a large built up area. It could be Glasgow, Aberdeen, Dundee, Edinburgh, wherever. The issue here is we've got a whole time fire station relatively close by. What I want you to look at just now is the tenability level, and it's important to note that because that's the point where the conditions in that room are so extreme, it is unlikely that anyone will survive in that particular room. The fire will start within 45 seconds of the smoke detector activating. Now, we all know that when we hear a fire alarm going off, we think it's anything but a fire. We'll do anything we possibly can, any excuse we can come up with to stop what we're doing, whether that be sleeping or whatever. But let's say that we're being conscientious here, and after 45 seconds, we get up, whenever that alarm has been off, we get up, we investigate. We see it's a fire and we call the fire service. So in this particular scenario, the fire appliances within 3 minutes of that fire first starting will roll out the door. Okay. Now, because we're in a built up area, within 5 minutes, the fire appliance will arrive at our front door. If we go slightly further afield, then that will take longer, and if we're out in the country, that will take significantly longer, particularly if we're in an area where it's a retained fire station. However, for this particular scenario, we have a very efficient fire service, of which I was part of, and within 2 minutes of that fire, of arriving, sorry, you will have water on the fire. 10 minutes from the fire starting, the fire service have got water on the fire. However, if you look at the tenability level, we would most likely have perished within 5 minutes. If we look at the same fire, the fire will start, the fire growth will increase until the temperature reaches 67 degrees. At that point, the sprinkler will operate and you will have massive cooling to the point where within 6 minutes, round about that, on most occasions, that fire will be under control, normally prior to the fire service ever arriving. A scenario from south of the border in Sheffield, where this project where 540 homes were fitted with sprinklers. On this particular occasion, the person had mobility issues and had their scooter parked outside the flat, and there was only one way in.
Sorry to interrupt, Danny, just a couple of minutes to go, thank you.
One way in and one way out of the building. So the fire started in the early hours of the morning, and it prevented the escape due to the close proximity to the doorway. That fire entered the house via the glazing units, which gave way under the heat, and the sprinkler head operated to prevent the fire spreading inside. The occupier was able to remain in the adjoining room. And as you can see here, the extensive damage that was caused to the outside of that front door. If that fire had broken in and had went unabated, there would have been absolutely no stopping it, and undoubtedly the people in there would have perished. And you can see from the picture there that the inside of that building, or the inside of that flat, is relatively clear. From the inside look now, it's quite obvious there is some smoke damage, but absolutely nothing like what we would have seen from the picture of the outside. So where's the evidence? As Benny alluded to earlier on, there have been two surveys or reports carried out by Optical Economics, who have carried them out independently. The first in 2015 for the Scottish Government, where it said it was about cost neutral for some dwellings and more cost effective in others. The kind of conscientious, or the contentious, part of that is that a key point to note is that in the United Kingdom, our actuarial cost of a life, our value is rated at about £1.7 million. If you go into Europe or indeed America, for example, that cost is round about $9 million or £7 million. So if you were to transpose those figures over, then the cost benefit would be greatly increased. The second was done in partnership between the Chief Fire Officers Association and the National Fire Sprinkler Network, which is the document that you can see in front of you. The NFSN is an organisation made up mainly of UK fire services. And the survey was carried out using real data from real life fire incidents. So their independent study showed that sprinklers worked efficiently as intended on 94% of occasions. And on 99% of occasions, they controlled or indeed extinguished the fire prior to the arrival of the fire service. 94% efficient, 99% effective. And if that's not pretty compelling evidence, then I'm not quite sure what is. And at that, I will pass you on to Keith. Thank you.
Good morning, everybody. Can everybody see the screen?
Yep, can see it great, Keith.
That's great. Good morning. As Fiona said, I'm Keith McGilvery, Chief Executive of BAFSA. Like Danny and Benny, I also was in the fire service and have had a lot of experience of fires, very sadly. I was delighted to see Scottish Building Standards and David Stewart supporting the campaign to get automatic fire sprinklers into housing in Scotland. But don't just believe the fire service. The British Standard says that sprinkler systems have demonstrated their value in protecting life and property in industrial and commercial applications for many years. And also by bringing in sprinklers that operate at an earlier stage in the development of fire, plus the recognition that large numbers of deaths occur in the home, has led to the introduction of sprinkler systems specifically for housing. So a correctly designed and installed sprinkler system can detect and control a fire at an early stage of the development and activate an alarm to warn the occupants of the building. So the standard we're looking at for installing sprinklers in housing and residential properties in Scotland is BS 9251. At the moment, the version that is out is the 2014 version. However, there is a new version due very shortly. We'd rather hoped it would be out in time for the new building standards. So they say that sprinkler systems can assist firefighters in carrying out search and rescue and by limiting the fire development. I know that from experience. When you're trying to search a building, when it's smoke logged, when there's a lot of fire, then it is very difficult for firefighters, and it puts firefighters as well as the residents at risk. The British standard covers the design, the installation, the components, water supplies, maintenance and testing of residential sprinkler systems, which are being introduced into housing to reduce the risk to life and minimise the spread of fire. So provided you follow the guidance and recommendations contained in BS 9251 and use a competent and certificated designer and installer, then you will have a system that will keep you safe and keep your house safe. So what is BS 9251? The British standard gives recommendations for the design, installation, the components, the water supplies, and the backflow protection, commissioning, maintenance, and testing of the fire sprinkler system when they're installed for life safety purposes in residential and domestic premises. The new standard will supersede BS 9251 2014, which will be withdrawn when the new standard comes in. As a code of practice, the British standard is guidance and recommendations. It should not be quoted as if it were a specification. The sprinkler system should be designed by a competent sprinkler designer in accordance with the British standard and the competent manufacturer's instructions. There are plenty competent designers out there. There are exams put up by the LPC and also by FIRAS, which are two of the third-party certification bodies. We actually provide courses as well for designers in order that they can sit these exams. For each installation, you should carry out full hydraulic calculations to ensure that the system has the required pressure and flow, and that determines what the water supply is that it will require. And this should be done for every installation. There's no one size fits all, so it should be purpose designed for that particular house that you're building or block of flats or whatever. The sprinkler system should be designed to facilitate easy maintenance. Too often we see systems installed, and then when they come to maintain them at a later date, they can't get access to the valves or the valve groupings or other items that they require to service. So ensure that it's designed to facilitate easy maintenance when the building is complete. When you're installing it, the British standard recommends using appropriately qualified and experienced people to install a sprinkler system. Third-party certified installers will have appropriately qualified designers and experienced trained fitters. These companies will have been certified by LPCB, FIRAS, or IFCC, who in turn are also audited on a regular basis, along with the companies that they certify. The three certification bodies are also certified by UCAS, the UK. The components of the system: all pipes, valves and fittings should be supplied, stored and handled, used and installed in accordance with the relevant British standard or other nationally recognised standards appropriate for the particular materials used. All systems should have at least one sprinkler alarm initiating device, and precautions must be taken to ensure that the system is frost protected, and that is particularly relevant in Scotland. In most cases, the frost protection will be required in the roof space for the pipework that goes in there or for the tanks that go there. In terms of the pipework can be laid in the roof space, and then the lagging for the roof or the insulation for the roof can be laid on top of it. In some cases, it may be required that further protection is needed, particularly if it's in a particularly cold area, and trace heating may be required for the piping. But again, this will be done, assessed by the designer and the installer and provided when they do that work. The water supplies. So the design should identify the requirements for the water. That's in terms of pressure, flow, and the duration for the sprinkler system. The system should be connected to a reliable supply, and these are, for example, mains pressure only, or water main supply boosted by a pump, a stored water supply, a pump supplied from a water tank, a regulated pressurized vessel, or a gravity-fed stored water system. And as Benny mentioned, you should also consult with Scottish Water. They have put out guidance and they are the water undertakers for Scotland. They will be giving you the supply of the water. When I say giving you, they will be charging you for the supply of the water and connecting it. So you should consult with them at a very early stage. The worst thing you can do is leave it to the last minute or wait till the design of the building is complete and then decide to go about getting the design for the sprinkler system. The design should be done for the building should be done hand in hand with a sprinkler designer. That way you can get the tank in the place you want. You may be able to share the tank if there's numerous houses in the development. And having it sorted out at the very design stage, the very early design stage, then ensures that everything will work smoothly.
Hi, Keith. Just a little check on time. Thank you.
Commissioning, the sprinkler pipework should all be clearly identified so that everyone knows that that water pipe is for the sprinkler system, it is not for drinking water. A leakage, hydraulic and alarm test should be carried out when the sprinkler system has been installed. And on a satisfactory completion of the commissioning tests, a compliance certificate should be issued by the competent person installing the system. This shows that the sprinkler system has been designed, installed and commissioned in accordance with BS 9251. The maintenance of the system. The system should have regular visual inspections as specified by the installer or the manufacturer. The system should also have a full test and inspection on an annual basis or when recommended by the manufacturer or installer. The results of all the tests should be recorded in the system's logbook, as is required with all fire systems. Every system must have a data label with the required information regarding the system, such as the flow and the pressure when it was installed, the date it was installed, the type of pump, etc. The occupier must also be given an instruction booklet for the system, which specifies the do's and don'ts of the system and basically familiarises them with the system and what they can do with it and what they shouldn't do with it. Items such as hanging coat hangers off sprinkler heads or swinging on the pipework are things that are definitely excluded, yet we have seen these in other houses. Thank you very much for your time and happy to take questions at the end when the panel comes together. Thank you.
Thank you very much, Danny and Keith. Another great set of presentations there, and thank you, audience, for all your questions so far. Just keep them coming. We are collecting them, and we are trying to stagger as many as we can and prepare them for the Q&A session. And at this stage, it's time for our third poll, which will be on your screen in the next moment or so. Do you agree with the new mandatory requirement to install automatic fire suppressions in new build, social housing, flats and shared buildings? Just give you a moment to complete that. Excellent. Interesting that 45% agree and 39% strongly agree. So it's quite clear and quite indicative what the feelings are from the audience there. So thank you. Thank you for completing that. And just moving on to our final presentation for today. Our final speaker is Bettina McDowell of International Water Mist Association.
So thank you very much for the introduction and thank you very much for having us today. I will talk about the water mist technology. I will explain how water mist works. I will say something about the benefits of water mist, then I will list some applications, and then we're going to have a look at the Norwegian way. So I suppose that all of you know that the fire triangle consists of 3 elements. That's the combustible material or fuel, and then there is the heat as well as the oxygen. And the thing is that water mist reduces 2 of these elements, the heat and the oxygen. And another thing is that water mist is a performance-based technology, which means that you will always get a bespoke system for your application. which is based on a real scale fire test, not on computer simulation, because water mist is not a one-fits-all concept. When it comes to the definition of the different water mist systems, you can see on the right-hand side that low pressure systems work with a pressure below 12.5 bar. High pressure systems work with a pressure above 35 bar, and systems ranging between these two figures are defined as intermediate systems. Now, this is according to two North American standards, FM 5560 and NFPA 750. These two standards were published about a quarter of a century ago, and just over 5 years ago, VDS published their guideline 3188. And in there, it says that there are basically just two systems: low pressure systems that remain below 16 bar and or 232 psi, and high pressure systems that exceed 16 bar. And what may also be interesting for you is that low pressure water mist systems are obviously much closer to traditional sprinkler systems than, for example, high pressure systems, and that sprinkler components can be used. Here you can see that NFPA, that's the National Fire Protection Association, a US American association, and then the European Committee for Standardization, have a slightly different opinion when it comes to the number of droplets that should be less than 1 millimeter or 1000 microns in size. However, what is more important than the question whether 90 or 99% of the droplets are less than 1 millimeter in size is the fact that water mist is defined by droplet size, and that the droplets that a water mist system produces interact with the fire so as to reduce the heat and the oxygen, what I already mentioned. The droplet size is a result of the pressure of the system, but also of the type of nozzle. And the smaller the droplets, the quicker they obviously evaporate. So how does that all fit together? What happens if a fire breaks out and the water mist system is activated? Water mist attacks the fire by spraying water through nozzles especially designed for this purpose, and the smaller the droplets, the larger the overall surface. I think you can see that very well on the right-hand side. And after a system has been activated, the released droplets evaporate and they turn into steam. And it is this steam or fog or mist or whatever you want to call it that interacts with the fire. Due to the enormous increase in the volume of the water droplets as they evaporate, the oxygen is displaced at the source of the fire and the flames are extinguished. During the extinguishing process, the oxygen content around the fire and only there drops. It nearly halves. And it is this low oxygen content that suffocates the fire. And this is called the local inerting effect. Further away from the fire, the oxygen content is normal. And that means that there is enough oxygen available for humans. What I would like to add is that when water evaporates, it expands approximately 1,700 times. So 1 liter of water turns into 1.7 cubic meters of vapor. And with small droplets, there is an increased surface area that will absorb heat and increase the potential evaporation. I would also like to add that there is an additional cooling effect that prevents reignition. However, the droplets ideally need a fire of a certain size. Fact is that water mist systems may have a bit of an issue with small fires because these fires do not have the force or the strength to evaporate the droplets, but still the system will keep the fire in check until the fire brigade arrives. When it comes to the benefits of water mist, I would like to highlight the diversity. I have mentioned that water mist systems produce very small droplets, and the result is that we have a suppression agent that is applicable on a broad range of fire types. And the reason for this is that the droplets turn into steam. This is really the key. In the chart here, you can see that water mist ticks nearly all the boxes, more boxes than other fire suppression systems. And I would like to explain something regarding the two columns on the right-hand side. These are the electric and cooking oil fires. With water mist, we are not looking for the effect of the water, the actual water extinguishing the fire, but the mist. So we want to provide a setting in which the droplets can turn into mist, and you can do this by making sure that the mist hovers above the flames and then sinks down to get the result that you obviously want. And the nozzle must therefore, of course, not point into the flames. Yeah, something about eco-friendliness and sustainability in connection with water mist systems. Well, first of all, a water mist system obviously uses water, and what is more natural than water? And then a water mist system uses a relatively small amount of water. You can save material due to relatively small pipes and tanks. We recommend the use of stainless steel for components that come into contact with water to avoid corrosion and thus contamination, and to support the longevity of the system, which in itself is a sustainable and eco-friendly approach. And the other thing about stainless steel is that it can be reused and thus be reintegrated into the life cycle. And then I would like to point out the reduced water damage, which means that after a fire there is less debris that has to be disposed of. Another challenge is the disposal of the residue after fire incidents in hazardous areas like, for example, the nuclear industry or in pharmaceutical and electronic manufacturing. When a fire breaks out in such areas, this can result in the release of many different toxins and chemicals from the fuel of the fire and or the gases, and the fire water gathers these substances and has to be picked up and disposed of after a fire. And this is a difficult job that becomes easier the less water there is. Another slide about the benefits of water mist. This is basically a summary of what I've already said, but I will add some points. So with a water mist system, you need a relatively small amount of water, a relatively small amount of space, and also the components are quite small. I have explained that water mist systems reduce the heat and the oxygen. I would like to add here, what I would like to add here is that water mist also wets the surroundings, thus affecting also the third side of the triangle that I showed you earlier on, although not as much as traditional sprinklers. Water mist does not harm humans. I've described the local inerting effect. Water mist systems are easy and fast to install. They're easy to retrofit. They can easily be extended. Some systems can be connected to the normal domestic water supply. The cooling effect prevents reignition. Another point is the room filling effect. Due to the size of the droplets, water mist is well distributed and fills many nooks and crevices within seconds of activation. Water mist can be carried around with the airflow and is therefore not depending on hitting the fire directly. It is therefore able to control or extinguish even concealed fires. When it comes to smoke control, water mist will efficiently cool the smoke layer, preventing the hot gas layer to contribute to further fire spread. The water mist will also clean out some of the smoke particles. And then the technology is proven to international standards and guidelines and is therefore ready to use. The standards and guidelines listed here are not in any particular order. We can ignore the IMO standards because IMO, that's the International Maritime Organization, and this is something we're not talking about today. Yes, in 1995, FM55 was published, followed by NFPA 750 1 year later. UL 2167 was first published in 2002, and I mentioned the VDS guideline was published just over 5 years ago. Then on the right-hand side, there are some national standards, including the 2 British ones. This list is not exhaustive, but most of the standards are listed here. For us, the most important standard is the ZEN standard. The EN 4972 Part 1 was published in December 2020. That's the part entitled Design, Installation, Inspection and Maintenance. In there, the concept that water mist systems are performance-based is defined and described. The European standard reflects the uniqueness of each system. It is rather the template for how a manual should be written and what it must contain. And there is indeed a DIOM manual for every system, which has to stick to the specifications provided by the standard. The letters DIOM stand for Design, Installation, Operation and Maintenance, and manufacturers provide this manual specific to their systems. And yes, talking about maintenance, uniform maintenance routines are applied throughout the water mist industry. Maintenance requirements for water mist systems are comparable to conventional sprinkler or gas extinguishing systems. And I would like to mention the metrics. The metrics can be found on the IWMA webpage. It is a chart containing all current water mist applications and associated fire test protocols that have been published by certification or test agencies. So I've had a look at some web pages, IWMA members web pages, specifically at the references section, to look at what kind of residential buildings and spaces their water mist systems protect, and this is the list I've come up with. And what I found was that especially the Nordic countries have been very open to water mist, and Norway really stands out, and that is why we are going to have a look at Norway in a bit more detail. So there is an apartment block in Oslo called the Bread Factory. I suppose it used to be one, and the 500 apartments in this block are protected with water mist. Then there is a flat in Kent. The gentleman who lives in this flat is someone who is mentally unstable, and therefore his flat needed to be protected to protect him, but also his neighbors. The water mist system in that flat is actually almost invisible. The idea had been to put the gentleman into that flat without him being able to detect the system, because the danger would have been that he would have tried to block or damage it. And actually, there was a fire not long ago, and the fire was put out by the water mist system. Yes, then there are Surrey Towers. There's a large domestic property with an atrium in London, Kensington. There are quite a few care homes in England. Houses in London. Then there are residential blocks in Slough and Colchester, a manor house in Surrey. And another slide with a couple of examples, including Windsor Castle. Okay, so Norway. In 2010, Norway imposed requirements for automatic suppression systems in residential buildings higher than 2 stories and with 4 units or more. In 2014, the Nordic Residential Water Mist Standard was published. Basis for the standard was, in fact, BSDD 8458. The residential water mist market is continuously growing. At the moment, we are talking 10% of the residential sprinkler market in Norway, obviously. And just to mention that BS 8458 is also the basis for the new residential water mist standard in the EN 14972 series. That is part 17 test protocol for residential and domestic areas for automatic nozzle systems. In 2019, the water mist market grew by 8% to over 29,000 nozzles, whereas the sprinkler manufacturers sold 80% less. At the beginning, the insurance company was quite skeptical, but now they handle water mist just like any other fire protection system. And looking at the fact that Norway installs more sprinklers and nozzles per capita than any other country, I would say that this country is a role model. And I would also presume that there is a lot of expertise in Norway regarding sprinkler systems, water mist systems, and the protection of residential and domestic buildings. Yes, if you would like more information, this is what I would recommend. A summary of a research project on RISE SE. Then there is Red Book Live. You can search for water mist and get some results there. And there are also the Norwegian sprinkler statistics. The numbers for 2020 have not been published yet, but I suppose they will be published soon. And then I will leave you with our Hall of Fame. There are actually more famous buildings protected by water mist, and I think that the Palace of Westminster is now protected or will be protected with water mist. And this obviously isn't a residential building, but I thought you would like to know about this. And yes, that brings me to the end of my presentation. Thank you very much for listening. And again, thank you very much for having us.
Another hugely informative presentation. Thank you very much, Bettina. It's now time for our Q&A session. So if you have any final questions, please do proceed in asking them through the questions tab. All of the presenters that we've had today will be joining the panel for the Q&A session, in addition to Ari Brandit from International Water Mist Association. Ari is employed at RISE Fire Research and has been since 1997, where water mist testing is active at scale, including the water mist testing for UPTUN, which is the upgrading of European tunnels. He's also president of the International Water Mist Association. So that's our panels coming on board now, and we will just proceed with starting our Q&A session. The first one being, do BAFSA have any opinions on the mist systems, and do BAFSA and Scottish Government have preferences over what is installed in homes?
In terms of BAFSA, we represent both sprinkler and water mist installers. Provided the water mist system is to BS 8458 and is installed by a third-party certified installer, then as far as we're concerned, it is a good system.
Thank you very much, Keith. Benny, any comments from Scottish Government point of view?
No, just to concur with what Keith just said, Fiona, we have no preference of one over the other, provided they're installed in terms of complying with the standard, or another standard that perhaps set a higher standard, one is available, an international standard, whatever, then we would have no difficulty in terms of, we don't have a preference one over the other. Sprinklers are just more commonly known, that perhaps have been more prominently used, but no, we don't declare a preference here.
Okay, that's great. Thank you for your feedback. Do you need separate qualifications from BS 9251 to install a water mist system?
BS 9251 is only the standard for fire sprinklers. BS 8458 is a standard for water mist, but this isn't a qualification. The qualification to install either system would be third-party certification by either LPCB, FIRAS, or IFCC.
That's excellent. Thank you very much for clarifying. Bettina, should a sprinkler be installed within a domestic home integral garage where there is or is not an internal pass door between the garage and house? That's for Bettina or Ari.
Yeah, would you like to take this?
What's that, sorry, Bettina?
I just was wondering if Ara would like to take this question.
That would be, as Bettina mentioned in her presentation, that the water mist systems is tested according to the use. So if you're going to use a water mist system in conjunction with a setting like that, you had to test it separately and document the effect of it. And if it works, it works, and then you should be able to install it, if I understand the question correctly.
Thank you very much. Sprinkler systems are supposed to have an annual check. Does this mean that building standards have to put a continuing requirement on each dwelling?
Currently, that continuing requirement isn't been proposed. However, they are required to be maintained as appropriate by the standard, and perhaps Keith would be the best person to ask in terms of what that kind of requires.
Thanks, Benny. Yeah, in terms of sprinklers and water mist systems, they do have to be inspected on an annual basis. This is both a visual inspection of the sprinkler heads, the pipe works and the valves to ensure there's no leakage. And where there are pumps, then also the pumps would require to be tested to ensure that you're getting the correct flow and pressure into the system. They would look at the specification plate that's on the system to ensure it's the same as it was when it was originally installed, and then record the test on an annual basis as well.
That's great, thank you. Is a ground floor flat accessed directly from outside required to have an AFSS?
So remember that a ground floor flat accessed directly from outside can be treated as a house for some of the other standards, but there was an amendment made to building regulations that required all flats, so that would be all flats regardless of height, to have automatic fire suppression systems installed. So the answer to that question is yes, it would require to have fire suppression fitted.
Excellent, thank you. What is the risk of Legionella in both a traditional sprinkler system and a supply tank and the mist system?
As far as water mist is concerned, there has been no record history or proof of the danger of Legionella, not that I know of.
Okay.
Exactly the same for sprinklers. There's no recorded cases of Legionella from sprinkler systems, and that is worldwide.
Excellent, thank you. Which month should we expect the guidance from the Welsh Government?
Really, that's a matter for the Welsh Government. We have been in discussions with the Welsh Government regarding the BRE-sponsored guidance that they're currently engaged in. It has been undertaken. There are several times over the past months where they have expected that report to be finalised and published. However, it's currently unavailable. The most recent instruction we received from them was that it would be within the next few months. What the next few months means is really a matter for the Welsh government to answer. It's not really. It's not going to be within the next week or so, if I can put it like that.
There's
at least that's not our expectation.
Okay, that's great, thank you. How would AFSS requirements be applied to new HMO licence applications in existing premises?
So remember, we spoke about conversions during the presentation. So if it was to be, depending what the existing premises was, but it was converted to an HMO with more than 6 people in it, then it would require to have AFSS, depending on the circumstances of that change.
Great, thank you. This is for BAFSA. We're aware that traditional water sprinkler systems are not suitable for electric fires. What is the opinion of the Scottish Government Building Standards with these systems and electrical fires? Should we be using these systems in the domestic system? Is there a chance of electrical shocks? Does that question make sense to you guys?
I'm quite happy to answer that, Benny, if you like.
Yeah, if you wouldn't mind, yeah.
There is no risk of electric shock from using sprinkler systems for fires in domestic dwelling houses. The droplets, and the same with mist, the droplets are so fine that it's unlikely that anybody would get an electrical shock. There is no recorded history that I am aware of where people have received an electrical shock when the sprinkler head or mist head is actuated. Clearly, all the rest of the problems with electricity and water would apply after the fire is extinguished.
Excellent. Is the use of water mist systems in social housing considered acceptable?
Well, provided, I think Keith already answered this, saying that provided it complies with the standard, which is BS 58, I believe, provided it complied with that standard, that was maintained to that standard, that was proposed to that standard, then yes, it should fulfil the requirements. But there are other aspects of the whole mist systems that have to be complied with, and that would be form part of the normal conversation or application process that would be had by the local authority to ensure that that standard was achieved.
Excellent, thank you. We've received another question in relation to conversion to all flats with ground floor and their own door, but I think we've covered that in a previous question as well, that, you know, it is all flats and it's regardless of entry situation. So that is the last question, and unless there's any final ones to come through. Nope, I think that's us for now. Excellent, thank you. So that's a wrap for today's session, and it's really just a case of me passing on my thanks, both in terms of the audience for taking the time to join us today, and for all the important questions, but most sincerely for our panellists too, and for sharing your thoughts and insightful discussion. Your expertise is always appreciated in that capacity, so thank you. We really do hope that everyone has found today's session useful. There's been a lot of questions submitted. We have recorded these questions, both in terms of the additional 3 events that we've ran before today's seminar, and for anything that comes through before the close of today, we will follow up with you separately to make sure that you gain some sense of the response. Your feedback is useful for future events and initiatives, so please do take the time to complete the feedback form that you'll receive when this event closes. And finally, please see all the links within the chat function for related sites, and that lets you stay up to date with the latest state of the art, and as this theme develops into the future. You can contact each organisation through these links for further information or references if required, and follow them all, including ourselves on LinkedIn, Twitter and Facebook. And that just leaves me to say thanks for attending today, and we look forward to welcoming you at our next event. Good afternoon, everybody. Thank you.